crew! How is everyone doing today? We're going to be talking about some cool stuff today. Let me get it all set up here so that we're good to get started. But last week I believe it was that we talked about starting to cover pulsars, and I was doing some research throughout the week, and honestly it got to be really interesting because it's not like pulsars aren't their own thing, right? Like, they are actually in the classification of neutron stars, and like neutron stars can become pulsars, and then they also can become these things called magnetars. So I want to go through each of these, kind of talk about them a little bit, and then just like go over some of the stuff that I learned that I thought was like really cool. And yeah, and if we have any questions, you'll talk about it as we go. So what actually is a neutron star? I actually did not know where these came from. So a neutron star is essentially like whenever you have a super huge star, like if you took our sun in the solar system, if you took the sun and it was like 8 to 20 times bigger than what it is currently, and then all of a sudden it's like it reaches the end of its life because, you know, maybe it's just this time. Anyways, so it reaches the end of its life. And what we saw whenever we were talking about black holes is that one of the options, whenever a star reaches the end of its life, it can collapse into a black hole. The other option is one of these. There's multiple options, obviously, but is one of these, is a neutron star. So you take this super massive star and it goes supernova and explodes and it's beautiful, and there's a nebula's made and everything. Whenever the nova goes away and it collapses into a hyperdense state, it could become a neutron star. And what's really interesting about this is like the forces on this are so intense that the electrons and the protons that existed in that star literally fuse together to make a neutron, which is where the neutron star comes from. And what's also wild is you go from like things that are like just absolutely ginormous to something that is 12 miles wide, or like roughly the size of this, like a city, like New York or something. And but it's way more dense. It is incredibly dense than the star. So just to kind of cover it, because it's literally going to be on the top of my mind unless I say it. The third thing that happens whenever a star goes supernova is if it doesn't have enough weight such that it's not that big like our star would, it would just collapse into a white dwarf. So but yes, so we're talking about neutron stars. These are really big stars that collapse, but they didn't have enough mass to go black hole. So what is a pulsar then? A pulsar is a neutron star that spins, and it has beams of radiation that are sent out from them. Now, it could also be, I think, like X-ray and like gamma as well, but yes, so they have like beams that shoot out. And so they kind of act like a cosmic lighthouse. And what's really cool about this is the reason that we say that is because whenever the pulsar, like if the beam is facing Earth, whenever it spins, it actually like will send out like a blink or like a pulse, and that makes it look as if, like, it's like a lighthouse, like it's the light spinning around the lighthouse waiting for the ships, and that's kind of what we see with the pulsar. And it ranges on how fast it spins, and I actually thought this was really cool, but the fastest one that we have found can spin up to 700 times like per second. So just think about that for a second. Literally something the size of like, a city, a big city, spinning 700 times a second. That is nuts. So I thought that was super cool. And I kind of like started digging into it, and I was like, how do we go from having this like super big sun or whatever to having something that spins? Like, I didn't understand that. And what that is called the conservation of angular momentum. So basically what's going on there is a star, like our star, even like the Sol, spins, right, as it's moving through the universe. And what it does is the conservation of angular momentum says that an item that is spinning, if you were to shrink it and make it more dense, it'll spin faster. right? So one example that you can think of is like a ballerina or an ice skater is probably like a better example. So an ice skater on the rink, whenever they go to like spin and tight really quick, they like if they're spread out and they start spinning, they'll spin, you know, a set speed. But if they bring their arms in to make their like form like smaller, they'll start spinning way faster, and that's conservation of angular momentum. So if you were to take like a really big object that is already spinning pretty quickly, just as an example, and have it go supernova and then have it crush or collapse on itself, then now you get like a pulsar. And I just think that's absolutely nuts, because it's just like, could you imagine seeing this thing just like absolutely just rotating like crazy? It would be so cool. So that's kind of like a pulsar. One of the cool things also about like a pulsar is that the thing with them is that they can spin literally so fast that they will rip themselves apart, and if it wasn't for gravity holding them together, then it would just completely explode. And I was like, oh, that is actually crazy, like that it can do that. But yeah, I thought that was really sweet. One of the things that also was really cool that I just kind of wanted to touch on is like its discovery. So the first pulsar was detected by Jocelyn Bell Burnell in 1967. So she detected these repeating radio pulses, and that's kind of like where this whole lighthouse like thing came from. But like at the time, what I thought was funny is that the scientists that were working with this named this LGM-1, which stood for Little Green Men. So it's like they were thinking that there was aliens. I'm sure they weren't actually thinking there was aliens, that, you know, maybe like I was out there. Who knows? Maybe it was me. But I thought this was really cool. I really wanted to mention it because I thought it was really neat. So we also have these things called magnetars, right? So we now know that a neutron star is whenever a rather large star collapses in on itself and it doesn't go black hole. We know that a pulsar is whenever that neutron star has a lot of spin on it. And now we have magnetars. So magnetars are like the drama queens of space, essentially, because they are an ultramagnetic neutron star. Like, their magnetic field is so strong, it's literally like 1,000 times a pulsar, which is already insane. And don't worry, I don't pay for YouTube. I don't pay for YouTube premium, so we're just gonna ignore that. But yeah, so these things are so intense. They literally have what was it called? It's like they can have star quakes. That's what it is. So like as the magnetic field is going around the magnetar, it will literally like crack and twist the surface of the star. And I was like, yo, that is insane. And they can also fire these massive X-ray flares. I thought this was like, this GIF is really cool because it kind of shows that. It's just like shooting it off into space. And what's also interesting is that the magnetars only exist for like 10,000 years. And they're super, super rare. Like, as far as we know, we only know of 30 magnetars that actually exist out in space. And so, like, this is like an incredibly rare event. And I just thought that was really neat. It's like, just saying this, the magnetic field that, like, we have on Earth that protects us, this thing has a magnetic field that is literally a quadrillion times as strong as ours. Like, it's just, these things exist out there is what's absolutely wild to me. It is just like, could you imagine even being near one? Actually, speaking of that, if you were to get near a magnetar, you could not get within, I don't remember the range, but if you get within a certain range, it will literally start to strip the atoms off of your body. And it's just because of how powerful the magnetic field is. And then it is like, there's also like a funny thing. It was like, if you get too close, then it'll also like wipe your bank account from your credit card because it's also sending out like electromagnetic, you know, radiation. It's like, okay, well, I think we have bigger problems if it's literally like stripping atoms off. But, you know, that's still like, still crazy. And the other thing is that these stars can still become black holes, right? I really wanted to like highlight this because our first Curiosity talk was about black holes. And I actually didn't know this. this was whenever I was looking at black holes, I always thought it was like if a star of a sufficient weight collapses, it can collapse directly in a black hole. That is true. That is true. But what I didn't know is that if a star collapses and it's not enough weight to become a black hole, that it'll go into a neutron star, which we talked about. But if that neutron star, as it exists in the world, or in space rather, if it were to find another star and either feed off that star, like it would gain its fuel or collide with it, or something to that effect, it can actually gain enough mass that it will collapse again, and it will actually collapse into a black hole. And I thought this was really interesting. Even more so is that if two pulsars were to collide, or maybe not even, it doesn't even have to be two pulsars, but a pulsar and like something else, if they were to collide and become a black hole, that's where we get the spinning black holes, like the ones that are really like. If you were here for our discussion on the first Curiosity stream, we talked a little bit about like static black holes and like spinning black holes, and how spinning black holes are super dangerous. Those black holes are called Kerr black holes, and that just means they're spinning. It's the person that discovered it, but yeah. So that's how those are formed. The spinning motion of the pulsar could create a spinning black hole. So I thought that was really cool. The other thing that I don't have on here, but the other option that can happen is that for both the neutron star and the pulsar, given enough time, both of them will become quiet neutron stars. And essentially what that means is that the neutron star will cool down to a point that it doesn't necessarily behave like a neutron star. I mean, it still will. Like, it's still going to be really, really small, like we said, city size. It's still going to be hyper dense, but it won't have like the magnetic fields as much. Those will begin to fade. And then in terms of like the pulsar, it'll actually lose its jets, and the pulsar actually, as it progresses through its life cycle, will actually once again become a neutron star, because it'll reach the point where I shouldn't say that. It's always a neutron star. It'll reach the point that it's not a pulsar anymore, like classification-wise. Like, it won't have the jets coming off. It won't be spinning super quickly. It'll slow down to the point of becoming a quiet neutron star. And I thought that was really interesting. And so I looked into what becomes of a magnetar at once it reaches its life cycle, or like how that works with the life cycle. And it's pretty similar. The two options though with that are, if like, and not two options, because the gravity will always hold it down. It'll still become a quiet neutron star, but the thing is, it becomes it much faster, is what I mean to say. Such that neutron stars and pulsars can be around for a very long time. Like, we're talking, I think it said like billions of years. Now, comparatively, a magnetar is literally so violent that it actually will dissipate in 10,000 years. Which I thought was absolutely nuts. And I'm getting a Discord call. Oh, I see. Hello. Call them back in a minute. Okay. So, speaking of collisions, one of the things I also want to talk about that I didn't know existed is a thing called a kilanova. So I've heard of supernovas, but I never heard of a kilanova. And essentially what a kilanova is this just, it's like a smaller version of a supernova. And specifically for like, now they're messaging me, it's throwing me off. But a kilanova is like a smaller version of supernova. And we actually, this was one of the things that was really cool, and I did talk about this recently, actually in the first Curiosity stream. I actually thought that the collision of two black holes was what we detected, or maybe it was two black holes that we connected in 2019. But in 2017, we actually received a gravitational reading of two pulsars running into each other and smashing into one another. And I thought this was really interesting, because this is also the birthplace of like your heavy metals. So if you have any gold jewelry or like platinum or anything that you're wearing, or like have gold in your house, this is actually where it comes from. So these super dramatic and powerful collisions are what causes those heavy metals to be made. and sent out into the galaxy. So, just like, I think that is such a cool thing to think about. Because imagine what we're taking. I don't know if I should say taking for granted, because those are still like precious metals, but you are literally potentially wearing something that has traveled billions of miles. It came from a super dramatic collision and traveled billions of miles to end up here, to collect, to become gold and something that we highly value. Thank you so much for the follow, much appreciated. Welcome to the crew. But now we can wear it, and I just think this, like, that's wild. I think that's so cool. So that is actually most of what I had for today's like curiosity stream. And I was just wondering, do you guys have any questions? Are there any thoughts on like the Pulsars, Magnetars, or Neutron Stars? Did you learn something new, or is there like something that you would want me to look into for the next curiosity stream? Please let me know. You know, throw it in the chat there, and we can either talk about it, or maybe there's something that from this discussion that you just have questions on that I may be able to like explain a bit more. Because I did kind of like fly through that. I won't lie.